Okay, so we're going to be doing lesson 6.9 and 6.10 part 2. So we are still working on solving equations with our exponential and logarithm problems. First video here, we're going to look at some examples of some more complex, just regular equations. And then after that, we're going to move on to some word problem stuff. So starting out with, I have a log base 4 of x and I have a log base 4 of 9. So we have a couple of logs up there. Okay. Now, how do I get rid of a log? Well, if it's a single log, I would get rid of it by just exponentiating with whatever that base is. And luckily, when I look at this, what do you guys notice about both these bases? Both those bases are the same. Okay? So I can just go ahead and exponentiate with my 4. Log base 4 of x. Okay, that's going to cancel like we want it to. I've got to do the same thing to the other side. 4 log base 4 of x. Or sorry, log base 4 of 9. Okay, going to cancel. Oh, wow. That really wasn't too complex of a logarithm, wasn't it? Okay, so if you have two logarithms on opposite sides, same bases, we're all good. It's not really that hard to solve. Now, if they're not the same bases, that's a whole nother story. And I don't even know how to solve those, so don't worry, they will have the same bases. All right, now we've got a log base 3 of x plus 4 plus a log base 3 of 3 equals 2. Okay, a couple logs here. Don't forget, we have a rule that if the bases are the same, like they are in this case right here, bases are the same, I can combine those. Remember, if we are adding, then we would be combining them into a single logarithm under multiplication. Okay, so I can combine those two together because whatever this is, plus, and I got that there, that plus sign in the middle tells me that I'm going to be multiplying those two things together. Okay, and that's from lesson 6.6. We can combine logarithms together like that. And honestly, you probably should combine logarithms because if I were to try to do what I did on the other one, log base 3 of x plus 4, and say I subtracted that other log to the other side, say I subtracted this over, okay, I can't exponentiate because that 2's in the way. So we're going to have to combine something in that situation like that. Okay, now, got a single logarithm. What's the base of that logarithm? Well, it's a 3. So I can go ahead and exponentiate with that base of 3. So that means my log base 3 of 3 times x plus 4 equals, if I do something to one side, I've got to do it to the other side as well. So that's going to be a 3 squared. That 2 moves up. We also could have distributed that 3 in. That could have made it look a little bit nicer. Okay, 3x plus 12 in there. These things will cancel. Forgot to write my base 3, sorry. So that log and that 3 will cancel. I'm left with a 3x plus 12 equals 3 squared, which we know 3 squared is 9. Subtract my 12 over, 3x equals negative 3, and x equals negative 1. So there's our answer. Okay, nothing too crazy there. Now, after I started doing this problem, I kind of got a better look at it. You actually could have made this a lot easier at the start, and I didn't even mean to do this. Some of you guys might have looked right here at that log base 3 of 3. Remember, that's a 3 to the first power, right? And those two 3's match. We could have just canceled that. Made this a log base 3 of x plus 4 plus 1 equals 2. Log base 3 of x plus 4, subtract our 1 over equals 1. Then I would be exponentiating. So 3 to the log base 3 of x plus 4 equals 3 to the first power. Those all cancel. I get x plus 4 equals 3. Subtract 4 to both sides. I get x equals negative 1. Okay, that's kind of a bad problem by my part there. I meant to make it so that we had to combine those two, but after I looked at it, we really didn't. Either one of these ways would be okay. Just be prepared if your logarithms do have the same bases, you can go ahead and look to combine those together. Okay? So those are a couple of complex logarithm problems. How about we do some complex exponential? Okay? Well, some of you guys might be like, that's really not that complex because they both have 5s. We've done problems more difficult than that. Okay? Remember, if they both have the same base, we're going to hit it with a log with that base. So that's going to be a log base 5 of x squared equals log base 5 of 5 to the x minus 12. These cancel. I'm left with an x squared. These cancel. I'm left with an x minus 12. Here's where the tricky part comes in. Okay? If I have an x squared and an x, what's the only way that I can solve a problem if I have an x squared and an x? Hopefully you guys are thinking that you've got to make it equal to 0 and factor. Remember, if there is ever an x squared and an x, you're going to have to factor to solve that. So we're going to go ahead and subtract our x, add our 12 over, subtract our x, add our 12 over. These would cancel. I end up with an x squared minus x plus 12 equals 0. And now I'm going to be ready to factor this thing. I do need to go ahead and apologize because I have made another mistake here. We need to make this a x plus 12 on all these. That is completely my fault. But what I've put up there for you guys, since that's a plus 12, I need to subtract 12. Subtract 12. We'll end up making this x squared minus x minus 12. That's my fault. What I had up there is not going to factor. Okay. But anyway, so I get those by itself. Okay. Got my logs with the same bases, so they canceled. Now I'm ready to factor. We're going to take 1 times 12, which gives me 12. And I need my factors of 12 that will subtract to give me the 1 that's in front of that. So 1 and 12, 2 and 6, 3 and 4. 3 and 4 would subtract to give me 1. So I have an x squared, a 3x, a 4x, minus 12 equals 0. And I need this thing to be a negative 1. So that means I'm going to want it to be a negative 4 and a positive 3. I can pull an x out of that there and gives me an x plus 3. I can pull out a negative 4 here. Gives me an x plus 3. So my factors on this are going to be x minus 4 and x plus 3 equals 0. Now remember, when you get your factors equal to 0, you got to set each factor equal to 0 to find your final answers. I get that x equals 4, and I get that x equals negative 3. So we have 2 answers that could be going in on this one. And remember, the fact that that's squared, that's what's telling us we're going to end up with 2 answers there. Okay. One more complex one that I want us to go over. I've got e to the 2x minus 7 equals e to the 5 minus x. Why is this one confusing? We got an e in there. What kind of logarithm do I use to get rid of an e? ln, the natural one. Hopefully you guys remember that ln has a base of e. So I'm going to hit both of these with a natural log. Okay. And that's what's going to allow that to cancel there. And it's going to end up canceling on this side as well. Okay, so ln and e cancel. I've got a 2x minus 7. Again, ln and e cancel. I've got a 5 minus x. Now that's not so hard. Add x. Add x. Get rid of that there. Add 7. Add 7. Get rid of that there. X and 2x give me a 3x. 5 and 7 give me 12. Divide both sides by 3. And I get that x equals 4. So nothing too crazy on those there. Just be aware, could be asked to factor on your homework. If you've got a couple of logarithms, remember if their bases are the same, you could be asked to combine those, whether it be by division or whether it be by multiplication. Plus sign means that you would be multiplying them together. If it was a minus in there, we would have been divided. It would have been x plus 4 minus, or sorry, an x plus 4 divided by 3. Okay? But there's a couple. Next video, we're going to do some word problems.